Good evening, I'm Nick Burma and I will be presenting a proof of concept for the Developing AI Strategy course with a focus on aircraft maintenance, safety and ground handling. The presentation, although brief, will cover off on topics of what artificial intelligence is, business and technology requirements for AI and machine learning, a real-world case study, the business problem at hand, as discussed in the topic slide, some ethical considerations for this topic, the nature of the team that will put this proof of concept together, challenges for AI and ML adoption, some key performance indicators, as well as a brief look at a data pipeline architecture for the proof of concept and the AI and ML strategy roadmap for the organisation. As with its biological counterpart, AI enables man-made objects such as machines, algorithms and computers to make decisions in response to particular inputs. Unlike biological intelligence, AI can perform repetitive and complex computational tasks much faster and more efficiently than humans. Machine learning, or ML, is a subset of AI comprising algorithms that teach themselves as well as learn and improve through experience. They are driven by data rather than explicit instructions used in traditional computing. There are a number of ways that algorithms or machines can learn, and the methods are determined by what data is input to the algorithm, the result being sought, and the means by which it should be established. But the general learning techniques are supervised, unsupervised, semi-supervised, and reinforced. A non-exhaustive list of business requirements has been provided here. In general, there needs to be a sound business strategy to begin with, a good understanding of AI and its limitations, and also the business should have an appropriate use case that AI could solve, as well as an ability to accept failure as part of the strategy. There must be a good ethical framework supporting the artificial intelligence initiative. From a technological perspective, the organisation should consider its own internal capabilities, the type of hosting arrangements that best suited, that is, on premises or on the cloud, and the availability of sufficient and relevant data, as well as its ability to properly prepare it for future or subsequent machine learning. The case study used here focuses on Airbus and its use of the Skywise system to perform predictive maintenance on its A380 and other aircraft. Artificial intelligence and data analytics are combined to analyse sensor inputs as well as structured and unstructured records to anticipate when components are likely to fail and thereby develop an optimal maintenance solution for that aircraft while minimising the impact on wider operations. For its part, this proof of concept seeks to apply this initiative to the safety aspects of maintenance and ground handling activities. To do this, it will use Amazon Web Services recognition video to develop a model of safe activity and those actions that could lead to a dangerous occurrence within the context of other surrounding activities associated with aircraft. It will also apply the Amazon Web Services Comprehend application to identify relationships within all records associated with maintenance and aircraft ground handling activities to determine the optimal mixes of experience, training and rest to reduce near misses and dangerous occurrences. While this is a proof of concept that may not progress further, ethics considerations are necessary. These will include issues of fairness and avoidance of bias, transparency of the algorithms used, privacy and communication with employees who may be impacted by this initiative. The proof of concept team will rely largely on internal members who will contribute to the project on a mainly part-time basis, particularly the subject matter experts from various affected areas such as engineering, maintenance, logistics and operations. However, it is likely that external data specialists will be required to ensure this component of the project will be adequately addressed, and without properly addressing the data issues, the project will not be able to succeed. There are a number of challenges that are associated with the adoption of AI, and these will need to be overcome. They include an unwillingness to recognise AI and machine learning, that these two elements will benefit the organisation, doubt over the effectiveness of the technology, and concerns over career and employment implications. These will need to be carefully and effectively managed in order that the proof of concept succeeds and that it can move further onto operationalisation. The key success of the proof of concept is endorsement to move forward towards operationalisation. Additional KPIs will comprise its ability to detect and, more importantly, predict potential dangerous occurrences within a dynamic operating environment. This may be activity-based or determined through analysis of the experience levels of a particular maintenance or aircraft ground handling team. The business outputs of this initiative will be reduced damage and injuries, coupled with increased effectiveness and efficiencies in maintenance and aircraft ground handling operations. Shown in this slide is the proposed proof of concept data architecture pipeline from the collection of data from closed circuit TV and records through a standalone proof of concept terminal and then into the Amazon Web Services products. And shown here is a 5-year AI and machine learning strategic roadmap for the organisation, going from year 0 now through to 5 years plus, with the intent of including newer and emerging technologies associated with this topic. Thank you very much.